Good morning to everybody. My name is Alessandro Paganelli, and the title of my presentation is System Architecture and Security Issues in Emergency Networks. My tutor is Professor Maurizio Casoni. This is a brief outline of my presentation, which is divided into three parts. The first one is about system architecture proposals. The second one will be about security issues in emergency networks. And the third part will be about some future work. First of all, an emergency network is a communication infrastructure for a public safety system that can be used to provide communication support to the first responders operating on the field, who are the people involved in the communication, in the emergency response from the very beginning. Some of its design requirements for such a network are reliability, availability, robustness, scalability, interoperability, and it should support many different services. We can translate this latter requirement into a QS1. In our vision, an emergency network should adopt standard and widespread technologies, mainly in order to make the whole system interoperable. Some of the technologies that we consider in our studies are IP as the main internet working protocol, as well as AEEE 802.11 family, 802.16, DVB-RCS, and 3G for what concerns with the transmission technologies. In the slide, you can find one of the system architecture proposals proposed by our research group. And before proceeding further, I need to introduce you some of the concepts that are depicted in this picture. First of all, what is the EOC, which stands for Emergency Operations Center. That is the main command and control center for the whole emergency. What is the MEOC? That is the mobile version of the EOC. And what are the first responders? That, as I said before, are the people involved in the emergency response. This network is divided into two layers. The first one, it is responsible for the interconnection between the various MEOCs to the EOC. And the second layer is responsible for the communication support to the first responders. The first layer is a mesh-based layer, which uses DVB-RCS as the main communication technology, and 802.16 for the terrestrial backup links, while the second layer has been dubbed quasi-star network, because if we consider this node, that is a first responder who has a special role in this network, and this is called special node, he acts as a hub for the other first responders. The technologies involved in this second layer are IEEE 802.16 for this main backhaul link, and 802.11 for the other first responders. The main benefits of this architecture are mainly it allows us for simple QS management, simple access control and AAA procedures, as well as simple traffic shaping and filtering. The main drawback is related to the special node, which is a single node in the network, and thus it is a single point of failure. At a glance, we can say that this architecture can be extended in principle by introducing redundant links and system, as well as new technologies such as 3G and LTE, mainly in order to increase its availability and avoid the single point of failure problem. Let me move on to describe the second part of the talk, which is about security issues in emergency network. In this slide, I listed the main properties the main security properties for a classical computer network. And at a glance, we can say that for an emergency network, the main properties that affect the design of its system architecture are authentication, data confidentiality, and availability. In particular, authentication needs to be quick and simple, and it needs to be viable even in the case of network disconnection. And lastly, it should allow inter-jurisdiction cooperation. We propose to adopt distributed authentication solution in order to avoid the presence of a single point that a single node that needs to be contacted in order to implement the authentication procedure. Our proposals are to use identity-based cryptography, self-organization or the trusted subgroup model, or simultaneous authentication of equals. For what concerns with data confidentiality and secrecy, we can say that it is usually implemented by means of cryptographic techniques, and the actual choice for our implementation will depend on the transmission standard adopted, the scope required for the confidentiality solution, and the presence of additional requirements such as QoS. Our proposal is to implement cryptography at layer 2 in order to allow the IP layer to operate with plain text packets, and in this way it can enforce QoS by applying traffic differentiation. For what concerns with availability, we can say that the main approach is to introduce redundant systems and technologies, both for what regards the computer system of the whole emergency system, and for what concerns with the telecommunication infrastructure. As for this latter case, some open issues arise, mainly related to the fact that by introducing new transmission and telecommunication technologies, we may have different logical networks that need to coexist and work together. For what concerns with future work, during my second year of my PhD, I will develop an assessment tool that can be used to evaluate the aforementioned proposal, and we are currently using and considering NS3, which stands for Network Simulation 3, as the main tool for evaluation. With this, I concluded. If there is any question, I'd be grateful to answer them. Thank you.